Alright guys, in this video we continue on measures of variability. So the first definition we're talking about today is called the percentile. Now first of all, let's take a look at the definition here. Let me pull out the marker. So the case percentile denoted a p sub k of a set of data is a value such that k% of the observations are less than or equal to the value. So there is a graph given down here. We can tell the P1 means first percentile. In this case, there are 1% of data set. The bottom 1% of data set are smaller than this P1. That's why it's called the first percentile. Similarly for P2, so there are 2% of the data set are less than or equal to P2. So this P2 is the second percentile. So same thing for the P98. So in this case, there are 98%. There are 98% of data are less than or equal to this P98. So this is called 98th percentile. Of course, this number here is called the 99th percentile. I think this definition is pretty straightforward. Now let's take a look at the example here. How to interpret a percentile. The graduate record examination (GRE) is a test required for admission to many U.S. graduate schools. The University of Pittsburgh Graduate School of Public Health requires a GRE score no less than. They require GRE score no less than 70th percentile for admission into their human genetics MPH or MS program. If they require GRE score no less than the 70th percentile, that means they want the GRE score in the top 30%. That's pretty much the interpretation, the rough interpretation of this example. Now let's take a look at the exact interpretation here. In general, the 70th percentile is the score such that 70% of the individuals who took the exam scored worse, and 30% of the individuals scores better. So that's coming from the definition of the 70th percentile. In order to be admitted to this program, an applicant must score as high or higher than the 70%, higher than the 70% of people who take the GRE. Put another way, the individual score must be in top 30%. That's pretty much same as what we just mentioned up here. That's pretty much all about the percentile. Okay, so once this makes sense, let's take a look at the definitions of quartiles. Quartiles divide data into four equal parts. The first quartile, denoted Q1, divides the bottom 25% of data from the top 75%. Therefore, the first quartile is equivalent to the 25th percentile. The second quartile divides the bottom 50% of data. Of course, this is Q2. The second quartile divides the bottom 50% of data from the top 50% of data, so that the second quartile is equivalent to the 50th percentile, which is equivalent to the median. So in this case, we're going to have Q1 is equivalent to the median. Begin. Number 3, the third quartile divides the bottom 75% of data from the top 25% of data. Of course, third quartile divides Q3. So basically, if we want to find out the quartiles Q1, Q2, and Q3, first of all, we want to find the Q2 first, because that's the median of the whole data set. We can find out the Q2 or the median by following the steps that we went over in the previous video. And then, once we got a Q2 or the median of the first half, will give us Q1. And then the median of the second half, or the top 50%, will give us Q3. Now let's take a look at the steps of finding quartiles here. Step 1, arrange the data set in ascending order. The reason why we did this is because when we are looking for the median, we need rearrange the data in ascending order. That's how we find the median. Step 2, determine the median M, or the second quartile, their equivalent, of course. Step 3, divide the data into halves. So observations below M and observations above M. The first quartile Q1 is the median of the bottom half, and Q3 is the median of the top half. So basically, once again, if we want to find the quartiles, we need to find the median of the whole data set first. And then the median of the first half, or the bottom 50%, would be Q1, and then the median of the top 50% would be Q3. Now, based on the steps we just went over, let's take a look at the example here about how to find and interpret quartiles. So in this example, given that there are 14 numbers in total, and all of them are given down here, and we want to find and interpret the quartiles for speed in the construction zone. I wouldn't read over the whole background information, okay? So basically, there are 14 numbers in total, and we want to find the Q1, Q2, and Q3. So based on the steps we just went over, we know that we want to find out the median first. So if we want to find the median, we need to find out the middle position first. Since we got 14 numbers in total, and 14 is an even number, so in this case, we want to find the two middle numbers, and the average of the two middle numbers will give us the median. Now, how do we find the two middle numbers? First of all, let's take a look at the position. So the position, the first of the two middle numbers would be, let's see, of course, in general, we want to find the n over 2 and n over 2 plus 1. In this case, n is equal to 14. So if we plug 14 back into here, we have 14 divided by 2 is 7. Of course, it's going to be 7th because it's the position of one of the middle numbers. And the second position would be 1 over 14 divided by 2 plus 1. So which is 7 plus 1 is equal to 8. And that should be the 8th. Once again, those two numbers are the position of the two middle numbers. They are not the value of the numbers we're looking for. So basically, we want to find out the middle two numbers lies in the 7th and 8th. So we got a 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So basically, the median would be equal to the average of the two middle numbers, 32 plus 33 divided by 2, which is 32.5. Okay. And then, since we want to divide the whole data set into the bottom half and the top half, of course, since we got 14 numbers in total, so the first half, or the bottom 50% would be the first 7 numbers. This is the first half. And the second half would be the second 7 numbers over here. And we know Q1 is the median of the first half. Of course, we have 7 number over here, so the median of the first 7 would be 28, because this is the number in the middle. So Q1 is equal to 28. And then Q3 would be the median of the second half. So the median of the second half would be this number over here, right? That's the number in the middle, 38. And that's how we find the Q1, Q2, and Q3. Of course, this is a Q2 as well. Now, let's take a look at the steps, the exact steps, but it's pretty much the same as what we just went over. Step 1, the data is already in ascending order. That's what given in the problem here. And there are 14 observations, so the median or second quartile Q2 is the mean of the 7th or the 8th observations. Therefore, the median is 32.5, which is the same thing as what we get over here. The median of the bottom half of the data is the first quartile Q1. So this is the bottom half of the data, and the median of that would be 28, which is Q1. The median of these 7 observations is 28, therefore Q1 is 28, and the median of the top half of the data is the third quartile Q3, therefore Q3 is 38, which is the exact same thing as what we got over here. The median is 32.5, Q1 is 28, Q3 is 38. Okay. Now let's take a look at the interpretation. Actually, the interpretation is just coming from the definition of the quartiles. So 25% of the speeds are less than or equal to the first quartile, 28 miles per hour, and 75% of the speeds are greater than 28 miles per hour, because the first quartile divides the whole data set into the bottom 25% and the top 75%. Similarly, 50% of the speeds are less than or equal to the second quartile, 32.5 miles per hour, and 50% of speeds are greater than 32.5 miles per hour, because the second quartile or the median divides the whole data set into the bottom half and the top half. Number 3, 75% of speeds are less than or equal to the third quartile, 38 miles per hour, and 25% of the speeds are greater than 38 miles per hour, because based on the definition, the third quartile divides the whole data set into the bottom 75% and the top 25%. That's pretty much how to interpret the quartiles. Once we know how to find the quartiles, there is no definition called the interquartile range. The shorthand word is IQR. Is a range of the middle 50% of the observation. So if we want, let me draw a picture over here. So this whole data set, and let's say this is a Q2, and this means Q1, and this is Q3. Now we know each part is 25%, 25%, 25%, and 25%. So based on definition, the interquartile range is a range of a middle 50%. The middle 50% is from Q1 to Q3, right? This part gave us the middle 50%, which means if we want to find out this range, we just need to use Q3 minus Q1 to find the IQR. So that is, the IQR is the difference between the third and first quartiles, and is found using the formula. IQR is equal to Q3 minus Q1. Now once we know the formula, it's very easy to find the value of IQR, right? Because in this case, for example, we know Q3 is 38 and Q1 is 28. So in this case, the IQR would be equal to Q3 minus Q1, which is equal to 38 minus 28 is equal to 10. So IQR is 10 in the previous example. We got an example here actually. Determine and interpret the interquartile range of the speed data. We know Q1 is 28, Q3 is 38, so the difference of the IQR is 10. Same thing as what we got up here. The interpretation would be the range of the middle 50% of speed of the cars traveling through the construction zone is 10 miles per hour. So this pretty much just coming from the definition of interquartile range. Okay, now once we know how to calculate the IQR, let's take a look at how to check for outliers by using quartiles. Step 1, determine the first and third quartiles of data. So in the previous example, we know that Q1 is 28 and Q3 is 38, right? Step 2, compute the interquartile range. Of course, IQR is equal to 10 in the previous example. And determine the fences. Fences serve as cutoff points for determining outliers. And we know two fences. We have two fences over here. One is called the lower fence and one is called upper fence. So the formula of the lower fence is the Q1, first quartile, minus 1.5 times IQR. So if we got back to the previous example, the lower fence would be Q1, which is 28. Would be 28 minus 1.5 times 10. 10 is the value of IQR, right? So that would be 28 minus 15, which is 13. And the upper fence would be Q3 plus 1.5 times IQR. So Q3 is 38, and then plus 1.5 times 10. So which is 38 plus 15, which is equal to 53. Now, once we get lower and upper fences, let's take a look at step 4. If a data value is less than the lower fence or greater than the upper fence, it is considered an outlier. So basically, once we get the value of lower and upper fences, we just need to get back to the original data set and say if there are any numbers smaller than the lower fence or greater than the upper fence. If there are some numbers lower than the lower fence or greater than the upper fence, they are considered as outliers. Now, let's get back to the original data set and say if there are any number are less than 13 or greater than 53 or not. So this is the original data set. Obviously, we can tell that there is no number less than 13 or greater than 53 because the smallest number is 20 and the largest number is 40. So there are no outliers in the original data set. So basically, this is how we check for the outliers by using the quartiles. What we need to do, just follow the 4 steps over here. Just find the Q1, Q3, and then calculate the IQR, and then determine the lower and upper fences, and say if there are any numbers less than the lower fence or greater than the upper fence. Okay, so this example is exactly the same thing as what we went over. Let's just read it over for quick. The first and third quartiles, Q1 28, Q3 38, interquartile range is 10, same thing. And lower fence is Q1 minus 1.5 times IQR, which is 13, same thing as what we got up here. Up here. And the upper fence is 53. So since there are no values less than 13 or greater than 53, therefore there are no outliers. Okay? So once again, if you want to find out the outliers of a data set, you just need to just follow the 4 steps over here. Okay, once we know how to find out the quartiles, let's take a look at the 5-number summary. The 5-number summary of a set of data consists of the smallest data value, a Q1, the median, Q3, and the largest data value. We organize 5-number summary as follows. 5-number summary, we want to find out the minimum, Q1, M, Q3, and maximum. So basically, if the problem, whatever the homework problem or the test is asking for a 5-number summary, what you need to do, just find the value of those 5 numbers and put them in this order. The minimum first, minimum, Q1, median, Q3, and a maximum. Now let's take a look at what does the 5-number summary of the previous example look like. So first of all, let's write down 5-number summary, and then we want to mean Q1 and Q3 and the max. So basically what we need to do next is to find out those 5 numbers from the original data. So we have already known that Q1 is 28, median is 32.5, Q3 is 38. They're all from the previous example we just finished. And I believe the minimum is 20 and the max is 40. I think that's right. Let me get back, double check. Q1 28, Q3 38, that's right. And the median is 32.5, that's right. The smallest number is 20 and the largest number is 40. So we're done. That's the right 5-number summary of the previous data set. So once again, the 5-number summary supposed to be organized in this order. So in this order here, once you got those 5 numbers, put them in this order, you got the 5-number summary. And then the very last section for this part is drawing a box plot. Now let's take a look at how to draw a box plot. So first of all, determine the lower and upper fences. So in the previous example, we know the lower fence is, the lower fence was 13. The upper fence was 53. Okay? And then number 2 says draw a number line long enough to include the maximum minimum values. Insert a vertical line at Q1, M, and Q3. So let's draw a vertical line here. So insert Q1 is 13. No, Q1 is not 13. I'm sorry. Q1 was 28. Q1 was 28, and the median was like 32.5, and the Q3 is what it was 38, I think. And based on step 2 over here, draw a number line long enough to include the maximum and minimum values. Insert vertical lines at Q1, M, and Q3. Enclose these vertical lines in a box. So basically, we just draw a vertical line above Q1, above median, and above Q3. And then enclose these vertical lines in a box, like this. And then step 3, label the lower and upper fences. The lower fence is 13. 13 should be somewhere over here. This is 13. We label the lower fence with the bracket. And the upper fence is 53, right? So 53 is this is like that. 53 is over here. And then step 4, draw a line from Q1 to the smallest data value that is larger than the lower fence. So this is not the smallest data value in the data set. It got to be the smallest data value that is larger than the lower fence. We know the lower fence is 13 and the minimum value is 28, so which is larger. No. The minimum number is 20, which is of course larger than the first quartile. Which is larger than the smallest value. So we just go ahead to find the minimum number, which is 20. 20 is somewhere over here, right? Draw a line from Q1 to the smallest data value that is larger than the lower fence. So we draw a line from here to here. And then we know that we need to draw a line from Q3 to the largest data value that is smaller than the upper fence. So this is not the largest data value in the whole data set. It should be the largest data value that is smaller than the upper fence. So in the original data set, we know this, the largest number is 40, right? Let me rewrite the 38 over here to make that clear. Okay, 38. Oh, sorry. And then since the largest data the largest data value is 40, which is of course smaller than the upper fence 53, and then we just need to draw a line from the Q3 to the largest data number. Okay, that's the step 5. That's the step 4. Step 5, any values less than the lower fence or greater than the upper fence are outliers and are marked with a star risk. So of course, obviously in this case we do not have outliers. So this would be the final version of the box plot. But in the future, if you have any questions, if you meet any questions with the box plot and there is outlier, you need to mark the outlier with a star like this. Okay, this star, and you'll write down the value over here that represents outlier. But in this case, we don't need to do that because there's no outliers in the data set. And let me... Okay, that's pretty much how to draw a box plot. I wish it does make sense to you. So once again, if you want to draw a box plot, what you need to do, just follow the 5 steps over here. Okay. Of course, don't forget mark the outliers. If there are some outliers in the original data set, don't forget to mark them in the box plot. So once we know, oh, there is one little notation I forgot to mention, is that these lines are called whiskers, which means those two lines are called whiskers, okay? They are called whiskers. Now, once we know this notation, let's take a look at use a box plot and quartiles to describe the shape of distribution. So let's take a look at the middle one over here. Let's take a look at this one. So in this one, obviously this is symmetric distribution, and based on what we went over in the previous video, we know that for symmetric distribution, we're going to have the median is equal to the mean, right? And we can tell that in this case, the length of the right whisker is the same as the length of the left whisker. So they are the same. They're the same. Now once we know that, let's take a look at this one over here, skewed right. Obviously, in this case, based on what we learned before, if it's skewed right, we're gonna have the mean is greater than the median, right? And in this case, the length of, not the length, the right whisker is longer than the left whisker. That makes the distribution skewed right. And let's take a look at this graph over here. Since it's skewed right, that means the mean is less than the median. The mean is less than the median, that's correct. And in this case, the left whisker is longer than the right whisker. So once this happens, once the left whisker is longer than the right whisker, the distribution would be skewed left. So that's pretty much all about using the box plot and the quartiles to describe the shape of the distribution. All right, I think that's pretty much all about this video.